Swayam Prabha. Digital India. Educated India.
Welcome back, and hope everybody is enjoying this course in project management. In the 15th lecture, which was the last lecture for the third week, so I just discussed with a simple Excel sheet and drawing the graphs for the quadratic util function. So as I mentioned in the last 3 or 4 seconds or last 1 minute for my class for the 15th one, I did mention that I will goes in the same way for the other 3 utility functions, which were exponential, then the logarithmic and the power function. So let us go through the example for the logarithmic one. So logarithmic utility function is ln of w, and remember w is always positive. So if I differentiate that and then use that double differentiation concepts and then go to a value, then find out a prime, the value comes out to be for a prime is minus 1 by w square. So w square is always positive, so the sign would always be negative for a prime. So with that, immediately come to the first point which is mentioned, which means it has got a decreasing absolute risk aversion property. So if I again differentiate that and use the concept of, so if I use the characteristics of r and r prime, the r prime value comes out to be 0, which means it has got a constant risk aversion property. And then you can go back to the slides and refer that what it means from the point of view of taking a risk, not taking a risk, or being indifferent to the risk. So in this example, again this thought out example, or I am again taking the values of w on the first column. These values are increasing by quantum of 1, 1, 2, 3, 4, and the values are given. This ln w, which is utility function, values are again marked. So if I find out ln of 1, ln of 2, the values are there. I have purposefully skipped u prime, which is d ln w of dw, which will be u prime, and the fourth column, which is also missing here. I have done it purposefully, so that means if you put these values in Excel sheet, do it. That is u double prime, and once you find out the u double prime, immediately all the calculations follow. You can use again, find out the value of a prime, r, and r prime. Remembering the fact that the calculations from a to r is simply multiplying the a value with w. So minus 1 into 1 is minus 1. If you go into this last value, 10 into minus 0.1 would be 1. So these values which I have written down for r are considering that I am basically taking 2 places of decimals, so that does not matter. So I have the r values and then the r prime values. So if you concentrate on the a prime values, which is the fourth column here in this slide, which is the 167th slide, and if you look at the r prime value, which is the last common in this slide column, so these r prime values are always 0, which means it has got the constant relative risk aversion property as just mentioned in the last slide. So it will make sense that what I was trying to prove using simple derivative actually comes out when I use a hypothetical example. So it makes a sense that what I was talking from the mathematical point of view also makes sense in the practical sense. So these practical values can be changed using any w or wealth in any utility function, which in this case is ln, and you can do the calculations. So based on that, if I draw the curve, you have the utility function as ln w, which is the pink color, the yellow one, the light greenish blue one is for a and a prime, and correspondingly, unfortunately, you do not have r prime because 0, it will be a straight line along the x axis. So the r and r prime values are given. Let us go to the third example, which is the utility function which is exponential in characteristics. So this a value, the parameter value is technically known to you. If you find out A prime and R prime, it comes out to be 0 and A. So, if it is 0, then we immediately know it's got a constant absolute risk aversion property, and if it is A is a constant, a parameter for the utility function, it has got an increasing relative risk aversion property, because A we consider as positive. In case it is negative, obviously depending on the example, but technically A is always positive. So, you can again do the differentiation to find out A prime, R and R prime. Again the same example, extending it for this utility function. Third example, values on given on the first column the W, second column is UW, third and fourth column are skipped for your usage only. You do the calculation, which is U prime and U double prime. Based on that fact, you find out the third column, which is shown in this slide, which is the 170th slide, which is the A, then you have the A prime. So, if you see A primes are all 0 as just mentioned in the last slide. Similarly, I find out R, R is multiplication of A into W, and then I find out R prime, which is again a constant. So, the value of A. So, you can see that whatever we discussed and using the simple mathematics also comes out in this simple example. So, it's constant absolute risk and positive absolute risk relative risk property. The exponential utility functions, it's again drawn. The pink one, I am following the same color combinations. Pink one is U, A is yellow, then greenish blue is the A prime. Correspondingly, then you have two different colors. It's very difficult to differentiate. If you, one is brown, which is R prime, and one is a little bit violet combined brown, which is for R. And if you draw the curves, you get this. So, use Excel sheet to find it out. The last example is basically the power function. So, if you use again the simple concept of mathematics or derivative, A prime is given as C minus 1 divided by W square. Again W square is positive, and as such W is positive. The C minus 1 would if you remember, I did mention the C value is less than 1 and not equal to 0. So, this will give you the property of A prime. R prime again you are finding a 0, which means it will give for R prime is constant relative risk aversion property, and for A prime it will be decreasing absolute risk aversion property. Continuing in the same sequence of explanation, I draw W, I write down values of W on the first column, UW, which is the utility function on the second column, third and fourth are skipped. Do it yourself, U prime and UW prime. Based on that, you find out A prime, R prime, and have a look. A prime is negative because C minus 1 would be negative because C is less than 1. So, it is negative, and R prime is 0. So, it is constant relative risk aversion property considering the last column, and A prime would give you that it is got a decreasing absolute risk aversion property. I draw the curves. So, I have U then A prime, R and R prime. So, if you see R prime, which was basically a constant value. So, this is as it is shown in the last curve where I am hovering my finger. So, this is the one. So, this is basically the line for R prime. So, I now consider concept of certainty equivalent. Certainty equivalent has some notion which we have already discussed. It is basically the concept used from the point of view of investment, from the point of view of finance, which is exactly equal to the mathematical concept of finding the expected value. But the reason why we are discussing is that certainty equivalent value would basically give you a very good notion that how you can make a decision according to what is the value of the certainty equivalent value, and based on that you can also make a decision whether the person does love risk, is indifferent to risk, and is basically a hater of risk. So, the actual value of the expected utility is of no use to us or no consequence to us except when comparing with other alternatives. So, you have different alternatives. If you remember the decision tree problem where you want to drill or you want to basically come into the market with the new moped, you made a decision between different arms based on the expected value concept. And I did also mention in the example where we were considering the decision tree problem 1 and decision tree problem 2, specifically for decision tree problem 1, I did also mention that in case if the expected values are same, then you go in the concept of variance. And it also, I also mentioned that in case if you want to make a comparison between risk and return, expected value and risk, you will try to basically take the ratio of return to risk, rank them from the highest to the lowest and take the one which is highest in there. Or if we reverse the ratios, by which is basically risk to return, then you rank them from the lowest to the highest and the one take one which is the lowest value. So, the certainty equivalent value, which is amount of certain wealth, which is the risk free concept, is basically the utility value of C, which is a constant value which will give me the same expected value as coming out from a gamble. Gamble means a decision. So, if you see the left hand side of this equation, you have UC. So, C is a certainty value for which the concept of probability would be 1, because if you see the certainty event, like you are tossing the coin, as I mentioned with a very simple example, the Cholet coin which is there, which has heads on both sides. In that case, the probability is 1, hence it will be multiplied by 1 such that it becomes UC only. On the right hand side, what you have for a gamble or for a decision or for a project or for an investment, you have the summation of different utilities multiplied by their corresponding probabilities. You find out if there are 10 arms, you multiply the corresponding utility with their probability and then find out that if it is equivalent to UC, then what is the value of C, such that you can see what is the actual certainty equivalent for that decision. So, how is the value of C useful? Suppose that we have a decision process with a set of outcomes, their probabilities and the corresponding utility values are given or known to you. In case if you want to compare this decision process, we can find out the certain equivalent, so that comparison becomes easier. So, without going into the rigmarole or doing detailed calculation, you have the value of C, then you can immediately rank which decision is better and which is definitely not good. To find the exact form of the util function, this certainty equivalent would also be useful. I will come to that with a simple thought out experiment and try to explain it from the point of view investment and a project. So, let us consider with a very simple example. Suppose you face two options. So, under option 1, you toss a coin. If a head comes, which is an unbiased coin, if a head comes, you win 10, while if a tail appears, you win 0. Under option 2, you get an amount W, M, sorry. Now, consider the utility function is quadratic in nature and the utility function is given like this, W minus 0.04 into W square. So, this is a quadratic utility function. It means that after you win an amount, the utility which you get by that investment is exactly based on the fact that the utility function is as given. Now, in the first option, which is if a head comes, you win 10. 10 is the amount of money which you win, but it does not mean the utility which is net worth for you. And for outcome 2, if a tail appears, you do not win any value, it is 0. So, 0 is the value which you win, you have to basically find it out from the concept of utility, what is the net value which accrues to you considering either 10 comes out or 0 comes out or whatever value depending on the example which is there. For the first option, the expected utility would come out to be 3. So, if I want to find out the expected utility, it would be based on the fact that how do I find out the utility. For the first one, probability is half for the head. So, it will be W is 10, 10 minus 0.04 into 10 square. So, this is one arm plus a tail comes. And what is the outcome which you are having? W is 0 minus 0.04 into 0 square. So, this value basically is 0. So, you calculate 10 minus 0.04 into 100 and then you divide by 2 and the expected value comes out to be 2. Let me calculate, just give me 1 minute. The first option it would be 3, and the second option with expected value of this, I think let me calculate. This is 10 minus 100 divided by 0 into 0.04. So, it becomes 10 minus 4 is 6 divided by 2 is 3, right, this is right. So, the first option, the expected value comes out to be 3. Now, this is the gamble. Gamble means there are two outcomes. Now, consider the second, which is the certainty value. Now, if you remember, just in the last slide, which was the 176 slide, I mentioned that for the certainty equivalent, you consider arbitrarily a value of C which you need to find out. So, if I want to find out what is the overall expected value of the outcome based on that value C, you will calculate it accordingly as I am showing now. So, your actual expected value for that situation is probability is 1, because it's is a output, the probability is 1 for this, it's a certainty value. It will be what symbol I am using? I am using the value of W m minus 0.04 into m square. So, this is the expected value of the certainty value. This will be equated to 3, because I have to find out what is the m value. 3 is the value which I calculated. From this you have a quadratic equation, solve it, find out m value. So, let me continue. While the second option has an expected utility as given, this one, to find out the certainty value we equate these values. So, this equation is equal to 3, from this we find out 3.49, which actually means that if in this example there was a gamble which gave me 10 rupees and another one 0 rupees with probability half and half, and on the other side of the table consider there are one gamble and one uncertainty one, a value of 3 rupees 49 paisa was kept on that table, then in that case when I as a person who has a utility function as given in this example, I would be indifferent in the sense my certainty value for this gamble and for the certainty one which is there are equal only at the case when it is giving me 3 rupees 49 one. So, what actually means is when I find out the expected value of 3.49, it should exactly come out to be the value of 3. So, the above example illustrates that you would be indifferent between option 1 and option 2. It can be many such options and you need to compare. Point 1. Point 2, for the gamble which I mentioned, if it is a project or an investment, it can have different arms, in the sense that in the first just last example, it was 10 rupees, one with probability half, 0 rupees, one with the probability half. So, these arms, let me use a, so let me first erase it. So, it had arms like this. So, they were giving me investments of W1, P1 till 1, 2, 3, 4. This is W4, P4. So, this is W2, P2. Then you have W3, P3, W. So, this will be 5. Sorry, this will be W4, P4, W5, P5. So, what I need to do in order to find out its equivalent with a certainty value would be Pi for 1 to 5 multiplied by UWI, this is the values which I have, sum it up and equal to the U value of C. So, C is given somewhere here, from that I find out the certainty value. So, there can be different arms also, what I am saying. Now, suppose if you face a different situation where you have an option 1 as before 10 and 0 with probability half and half, but a different option C where you get 5. Then obviously you will choose 2, because 3.49 gives you an utility which is exactly 3, but 5 would give an high utility which is more than 3. So, hence if I want to find out what is the utility for that value of 5, it comes out to be 4. So, I will be more tempted to take the certainty decision which is there. That 5 is not the certainty value, 5 is an outcome based on which I with my utility function as given would be more inclined to take the certain event. But if I want to find out the certainty value between the gamble and the situation, it is 3.49, such that I am indifferent. For the venture capital problem, if you remember, there was a government bond giving and there were 3 options of 10 lakhs, 5 lakhs and those examples with probabilities of 40, 40 and 20%. For the venture capital problem, the certainty value for the option 2 comes out to be 370,881, which is 3,70,881, as the overall utility of that certainty value comes out to be 609. If you remember, the 609 was the expected value. So, based on the fact that the utility was quadratic, my certainty value would come out to be 3,70,881. So, if that amount is kept, so that means I would be indifferent between the gamble and the certainty decision which is there on the other side of the table. So, any value greater than 3,70,881 would definitely mean I would be better off taking that non-probabilistic outcome. So, continuing with the discussions, a risk aversion person will select an equivalent certain event rather than the gamble. A risk neutral person will be indifferent between the certainty equivalent and the gamble, and a risk seeking person will select the gamble rather than the certainty equivalent. Now, let us do a thought out experiment how we can find out what is the characteristics. So, I will spend few minutes here. Consider the graph which is there in front of me. So, there on the y axis these c values are the certainty values which are to be plotted, and on the x axis the so called outcomes for the gambles are given. So, which is A, B, A1, B1 whatever it is, but here let us consider that A and B are given. Now, let us for the time being draw a 45 degrees line. So, this is the 45 degrees line which you have, and let us try to analyze the problem. Consider I know there is a gamble with probabilities unknown to me, consider half and half. It can be P1, P2, but considering there are 2 outcomes, but the sum of the probabilities are 1. Consider is a unbiased coin, probabilities are half and half, and I have A and B as the amount, whatever the A and B amount is. Now, I know that the actual expected value of that gamble is A into half plus B into half, which would be the midpoint here. So, midpoint I draw, I am trying my level best to use my drawing skills. So, this is the middle value, and I go horizontally onto the left. So, consider this is some C star. Now, I place the gamble and keep a value of C star here. Now, if you see the straight line, it means that actually the utility function is linear, because if I give 10 rupees, my utility is 10 rupees, because UW is equal to W. So, that is why it is a linear line. Now, coming back to the conclusion of the example, I have the gamble out, the values are given A and B, probability half and half on the left hand side, and on the right hand side there is a certainty, there is no probability, and I have kept a C star value, which C star is known to me obviously, and I ask the other person, place these 2 examples, and I ask him or her what decision would that person take, and C star is also known to that person because he or she sees it. Similarly, A and B is given. Now, consider the person says that he or she is indifferent. If that person is indifferent, it means that the certainty value for that decision for that person is C star. Technically, it would mean that the person is indifferent, hence the point as I marked is right. But consider 2 different scenarios. Person says that he or she would definitely take C star or not the gamble, which means the certainty value for the case for the gamble value is less than C star for that person, because if it was equivalent, certainty value would have given the decision which would have made that person indifferent between that value which is not C star and the gamble. But as C star is more, hence the person is more inclined to take the certainty actual event. On the other case, if the person says no, I would not take the value of C star, I would take the value of the gamble, then it would mean that the person has a value for that particular gamble, which means the person is inclined to take the risk. So, now with these two scenarios, slowly let us start changing the values of the problem. Let us change A and B, and I mark it on the x axis. Similarly, as I change A and B, C star value would also change. So, I keep asking the person which decision will he or she take. Would it be C stars which are changing, C star 1, C star 2, and correspondingly values which are calculated based on the expected value, and A, B values are changing. The person would basically give me an answer such that I will be in a position to draw the so called utility function on an empirical sense for that person, and if these lines are plotted, points are plotted, it can either be a set of points below the straight line or it can be a set of points above the straight line. And that would come out as you keep doing this thought out experiment, provided the person is given a rational answer, and this comes out to be true. And this is a very simple thought out experiment. You can basically fine tune it in much better way to get the exact answer. Now, if you see these graphs, the straight line, the line which is above and the curve which is below. Now, let us make a one-to-one correspondence to what we have just done. The colored scheme is not there, so you would not be able to immediately understand. If you remember the blue one, the green one and the red one, so in this case it was increasing, it was decreasing, and it was constant. So, if you try to bring a one-to-one correspondence here, the actual property of that person, whether that person loves risk, whether that person hates risk, or whether the person is indifferent to risk. Now, if that person loves, hates, or indifferent to risk, you know that as per the concept of economics or say so called concept of utility concept, the utility can be of 4 types generally: quadratic, exponential, logarithmic, and power. And we also know what are the properties of R, R bar, A bar. Based on that, you can immediately classify that person as being a risk averse person or a risk hater person or a risk indifferent person, such that using the simple example of a gamble and the certainty value which is there in front of you, and you have laid that in front of that person, you can find out what is the characteristics, and based on that you can judge the investment concept or the concept of money being utilized, the amount of money being utilized by the person for different projects for making a particular decision. So, with that I will end this class, and which is the 16th in number, and start with the 17th one depending on the different concept of utility, and slowly try to cover utility functions as fast as possible, and then again utilize this concept of utilities in the project management sense. Thank you very much for your attention. Have a nice day. Thank you.